Consider the open feed water heater FWH shown in the figure given below. This is the figure given of open fed water heater. Specific enthalpy of steam at location 2 is 2624 kJ per kilogram. Specific enthalpy of water at location 5 is 226.7 kJ per kilogram. And the specific enthalpy of saturated water at location 6 is 708.6 kJ per kilogram. If the mass flow rate of water entering the open feed water heater at location 5 is 100 kg per second, then the mass flow rate of steam at location 2 will be dash in kg per second. And this we have to round off to 1 decimal place. Let's say the mass flow rate at location 2 is M2, at location 6 is M6, and at location 5 is M5. Okay, and if we apply the energy balance for open feed water heater, so let's write here applying energy balance for open feed water heater. Okay, so if we apply this, we can write M2H2 mass flow rate of water at location 2 into enthalpy at location 2, specific enthalpy, plus M5 into H5 should be equal to M6 into H6, right? If we apply the energy balance equation for this open feed water heater, because 2, 5 and 6 are involved here. Now in the diagram, if we observe that M6 is equal to M2 plus M5, right? Because whatever the mass flow rate is here after it exits the turbine and from the open feed water heater, that mass flow rate is here before it goes to the pump, okay, high pressure pump. So here we can write, so if we substitute this here, this M6 is equal to M2 plus M5, this will be equal to M2H2 plus M5H5 is equal to M6 is M2 plus M5 into H6, right? Now the values are given here in the problem. So H2 given to us is 2624 kJ per kilogram. H5 is given 226.7 kJ per kilogram. H6 is 708.6 kJ per kilogram. M5 in the problem it's 100 kg per second, and M2 we need to calculate. So from here, if we substitute the values, we can write M2 is equal to M5 multiplied by H6 minus H5. I've taken this term to the right hand side, divided by H2 minus H6, right? We can just substitute the values here. This is 100. H6 in the problem is given as 708.6 minus H5 is 226.7 whole divided by H2, that is 2624 minus 708.6. So after doing the calculation, we'll get M2 is equal to 25.159 kg per second. Let's go back to the problem and fill in the blank. So the mass flow rate of steam at location 2 will be, we have to round off it to the 1 decimal place. So we can write the answer as 25.2 kg per second. Now to get detailed information on open feed water heater, you can refer to the NPTEL course lecture number 10, Feed Water Heaters on Steam Power Engineering by Professor Vinayak N. Kulkarni of the Department of Mechanical Engineering at IIT Guwahati.